Dear participants, we'll start meeting in within 5 minutes. Let everyone to join.
Shall we start? Actually, it will take a lot of time otherwise.
Sir, we are starting up now. Okay.
Mhm.
Mm. Okay. Am I audible to everyone?
Yes, yes, you are audible. You are audible.
Okay, sir. So, good evening, everyone. I am Anuj Kumar Mehta on behalf of EcoFast Agri Solution. I warmly welcome you to day 9 of the Winter Nurture Training Program UNNAT KRISHI 2026. It is truly inspiring to see such energetic participation through this program. Your presence reflects your dedication to learning, innovation, and the advancement of sustainable agriculture. Today's session holds a special importance with agriculture rapidly transforming through infrared spectroscopy and precision farming. It has become essential to understand how this advancement can be effectively integrated into sustainable practices. We look forward to gaining valuable insight into how infrared spectroscopy utilizes in rapid soil health that help in shaping the future smart precision and sustainable agriculture. Now, it is a great honor to introduce our keynote speaker for today, Dr. Dikshant K. Dr. Nishant K. Sinha. Dr. Nishant K. Sinha graduated from Banaras Hindu University in 2005, postgraduate in 2007, and a doctorate in 2010 from the Indian Agriculture Research Institute, New Delhi. He is a senior scientist at the Division of Soil Physics, ICR, Indian Institute of Soil Science, Bhopal, Madhya Pradesh, India. He used modeling approach to understand the impact of climate change on agriculture and the environment, particularly throughout land use and land cover
ठीक है,
change.
ठीक है. I shall deliver now. No issue. That you have introduced me enough. So that can I share slide now?
Yes, sir. Welcome, sir. The virtual
Yeah,
stage is
yes.
yours.
I'm
Can you
sharing the
start with
slides.
presentation?
Okay. That
Okay, sir. You
just,
can start from your.
actually that you are doing from. Let me do the thing. Is it visible?
Yes, sir, it is visible.
Now I think it is in slideshow mode, na?
Yes, sir.
Huh?
It is clearly visible.
It is in slideshow mode.
Yes, sir, slideshow mode.
Pakka?
Presentation mode.
Presentation
Yes,
mode,
sir.
na? ठीक है.
Yes, sir.
Thank you. Thank you. Thank you. Thank you very much. And very good evening to all of you. And I hope all our students here, some are the lecturer also. All our students here who is joining.
Sir, students, some are PhDs and some are professors.
Okay. Thank you. Thank you very much. And very good evening to all of you. So I just the organizer has mentioned that I'm going to deliver a lecture on the infrared spectroscopy and its potential for the rapid soil health assessment and precision agriculture. So that my purpose is that, and today what we are going to discuss, that is there any alternative way to analyze the soil? So that everybody presently what we are doing is that we are collecting the soil samples analyzed through the conventional method, where the number of the chemicals are used to extract the soil information. So that is there some other methods to by which we can uh, extract the information of the soils? So that is our purpose today, to make you acquainted that there are some method are existing here, so by which you can extract the soil health information. So but the first question is that why we need it to analyze and why we need the soil information. So here you can see that I'm just showing our India map here. So in that here, yeah, here just I want to share that in India naturally we are having the 7 order. Generally the soil is having 12 soil order, but in India out of the 12, 7 is having a present in India. So that overall you can see that we are having the more than 1200 the soil family. And if you go further down, so that we are having the 6,000, more than 6,000 soil series and more than 20,000 the soil mapping unit. So these are the natural variations we are getting in the soils. So but in all these variations are that in the different agro ecosystem, the peoples here, farmers are doing the different management practices. I know that the different crops are grown in the different soils. So the different crops, you are applying the different management practices, you are giving the varying the nutrients, varying water content. So that these all the anthropogenic management practices is creating the soil's variation. So the soil is having a lot of variations. So to know about our soil, first and foremost thing is that to quantify those information. So that if you are talking in general, in particulars, then you can see that why we need the soil information. So soil information, first we need to know that we should know about the, अरे देखिए ना बार बार ना notifications का sound आ रहा है. Can you close it so that I am getting irritated? The notification sounds. Hello. So that
Yes, sir. Hello.
notifications को थोड़ा mute कर दीजिए, so that I will not able to listen the notifications. So that we need the soil informations. For the first and foremost thing is for the sustainable for the foundation for the sustainable agriculture. So that if you want to develop the different kind of the management practices, you must know that what kind of the soils you will have. Second thing that you know the soil information is that generally presently what we are doing, we are applying the general recommended dose of the fertilizer. Suppose that for the wheat we are applying the 120 kg nitrogen management, 120 kg the nitrogens. Then for rice, all 130 kg of the nitrogen we are applying. This is the general recommended dose for all the agro ecosystem. But now we are talking, because of fertilizers, we are importing a lot of fertilizers from the other country, so that almost that the per year government is giving amount about 2 lakh crore 2 lakh crore subsidy on the fertilizers only. You cannot imagine that how much money government is spending to lower down the fertilizer prices. So for that, we need to save those fertilizers. We need to apply the precision and nutrient management. So that for that also you need the accurate estimation of your soil properties. Then the third is for the climate change mitigations, you need the different soil informations, because that how the soil's organic carbon is changes, how the nitrogen is behaving, phosphorus, potassium, all kind of the things you needed. Also the different kind of the models we are using, so that in that model the different soil information is used as the input. So also for the soil degradation, first and foremost thing is that to having the soil information. Also if you go for the certification for the sustainable, say, organic farming, yeah, natural farming system, the certifications, you need the soil information also. And very recently, some of you might be knowing about the carbon credits. So that in the carbon credit, that you must know each and every year the soil's organic carbon, the changes in the soil organic carbon per year under the different management practices. So if you estimate those soils organic carbon, it is actually not the soils organic carbon, it is a total organic carbon. It cost is around the one per sample 1,000 rupees you need to spend to estimate the soil sample. So in a way it is a very costly affair. So we need some the handy methods, some the low cost methods to get those information at the very low cost. So you can see that how the things are changing, from the visual assessment to the for the digital assessment we are coming into. During the 1917, we are not worrying about the soil health. Only we are worrying about the whether our crop is growing good or not, so that we don't bother about the soil health. But now the things are changing. Just after the green revolutions, after applying we are concerned about more about the soil health. But now you can see the transitions of the soil health from the visual and the digital. Now the present era of the agriculture is called agriculture 4.0. That is called the digital agriculture era, where we are using the different digital tool to quantify the different parameters. So that here we are going to discuss these parameters. So that what are the alternative way to quantify the soils. So here you can see that there is the one method, the conventional soil analysis, where you know about the conventional soil analysis and what type of analysis you were doing during your BSc. Another is the soil spectroscopy, where we are using the electromagnetic radiations to interact with the soils, and here the no chemical is involved firstly. Okay, so that through the electromagnetic radiation is going to interact with the soil properties. Then the soil property is the observing some of those electromagnetics and giving the spectral signature, and by using the different machine learning and artificial soils, and here the no chemical is involved, and we are quantifying those observations band. So that is the things we are doing under the soil spectroscopy. And if you are comparing the conventional methods and soil spectroscopy, here you can see the accuracy is almost similar. Cost is the low. Cost in the spectroscopy is the low. It is a very time efficient. So that once you have developed your own models, and then within the second you can quantify your soil property using the soil spectroscopy. And also it is very easy to use. But first and foremost thing is that, and the PhD institution, you must know that what is the soil health and how you can quantify the soil's health indices. So first you need to develop the management goal. So that suppose as an agriculturist, your management goal is to increase the crop production. So here first column it is coming the crop management goal. Then there are the different soil functions will come. Kya hoga soil function? What the first soil function could be that our soil should be the good. Functions could be our but changes. That means ki there are more salt, the more acidity, the soil is has buffering capacity. So the suppose that to achieve the higher rate, we need the three soil function. Now you need to decide that for the particular soil function, what kind of the indicator is the needed. Suppose for the providing the nutrient contents, you need the indicator, you need to quantify the indicator like the soil's organic carbon, you need to quantify the P, that available nitrogen, available phosphorus, available potassium. And for the soil function, as I mentioned, that it provides the plant and crop anchorage, so that you can go for the soil compactions, bulk density kind of the thing. And the third function, which is the buffer and other kind of the thing, just I mentioned that. Here you can, yes.
The presentation is not showing actually.
नहीं, अभी हम तो एक ही में चल रहे हैं, अभी एक ग्राफ दिख नहीं रहा,
प्रेजेंटेशन नहीं शो हो रहा है सर.
क्या शो हो रहा है?
बस आपका स्क्रीन आ गया, प्रेजेंटेशन कट आउट हो गया.
कौन सी, अच्छा कौन सा स्क्रीन दिख रहा है, बता पाएंगे आप?
बस आपका फोटो दिख रहा है, प्रेजेंटेशन फिर से आप
क्या दिख रहा है बताइए मुझे. मेरा फोटो दिख रहा है.
हाँ, प्रेजेंट स्क्रीन नहीं दिख रहा है प्रेजेंटेशन का.
ओके, अभी दिख रहा है? अभी भी नहीं दिख रहा है?
नो सर.
आपका नेट थोड़ा स्लो है क्या? ठीक है, मैं कोशिश करता हूँ. अभी दिखा कुछ? हाँ, एक तो किन्हीं ने थंब दिखाया. ठीक है,
अब दिख रहा है सर, अब ठीक है. ओके,
हाँ. शिवेंद्र ज्वाइन किए क्या?
यस सर, आई हैव जॉइन्ड नाउ. ओके सर.
हाँ, now that I think it is okay. So that my purpose is that the number of the indicators that we need to quantify based on the different soil functions. Okay. Then that because here you can see that indicators we are using, but how to integrate those indicators. Suppose bulk density has a different unit. Okay, soil's organic carbon has a different unit. So the different soil properties is having the different unit. So to remove those unit, what we need to do, we need to transform into a score. Okay, so here we are using the different kind of the score, like the more is better, the less is better, and the optimum is the better. Suppose why the more is better? For example, if in soil's organic carbon is the more, that means it is good for the soil health. But so for example, bulk density. If the bulk density is the lower, the soil quality is the good. So that means the lower is the better. And the pH, if the pH is the optimum, then our soil is the good. So that means the optimum is the better for the pH. So the different type of the score functions we are using. Once we will having the score, we will transform the soil property data into the score. Then we will integrate into the index value. So that this is the overall process. This is a very good information for the I must say that MSc and PhD student, how to develop the soil quality indices. Even there you can use it for your thesis work also, for quantification of the other soil quality indices. So you can see that this is the one meta-analysis. That meta-analysis is those kind of the analysis which is done on the published work. So that this is the meta-analysis and for the globes. And here you can see that which kind of the what type and what which soil physical properties, chemical property, and the biological property is good enough for the assessment of the soil property, assessment of the soil health. Here you can see for the soil physical indicator, you can see the water storage is the one of the most prominent the soil property tools for the selections of the soil quality. Okay, kind of the if you go for the soil chemical indicator, then the total organic carbon is one of the best soil property to get selected for the soil health assessment. So my purpose to show this slide is that these are the rank of the different soil property which can be included to quantify the soil physical property of the given location, for your location. So now that we have understand that we need different soil properties we need the different soil properties to quantify the soil health. Now the question is that how to quantify those soil property. If we are going to the field and collect the soil sample, then coming back to the laboratory and analyzing through the bed analysis method, it would be hard to analyze a number of the soil samples. Suppose, for example, here you can see that the similar studies. Suppose you can see that you are analyzing your soil samples for the Punjab and Haryana. This is the map of the Punjab or Haryana. So that if you collect the one sample in a 25 into 25 kilometer, then the total sample will be the 231. Okay, but you can see that it is a scales of the soil sampling. One samples you are collecting in the 625 kilometer squares. Okay. Then if you will collect the total number of the 10 into 10 kilometer, the total samples would be the 1100. Okay, but still you are collecting the one samples in a 100 kilometer square. Okay, and then if you will able to collect the 5 into 5 kilometer, that means the 25 kilometer square, the total samples will be collected is the 4000 approximately. But you still let's see that again in 5 into 5 kilometer, that means you are collecting the one sample in a 25 kilometers. So this is the 4,000 soil sample. But for the precision agriculture, you need soil sample into the 10 into 10 meter square. You cannot imagine the volume of the soil sample getting collected for getting the analyzed for the precision agriculture. So by the conventional method, we cannot do that type of analysis. So suppose any one of you collecting you go to the fields, collect the soil sample, analyze it in laboratory for the single properties. You cannot do the more than 30 soil samples in a day. So imagine the lack of the samples. How can you do? So we need some alternative methods to quantify the soil samples, and the solution is the soil spectroscopy. Soil spectro is nothing. Here is the two word. Is the one soil spectroscopy and the soil. A spectroscopy is nothing but it is the interactions of the electromagnetic radiation through the matter. Here our interacting body is the soils. So that's why we are naming it the soil spectroscopy. Okay. And in soil spectroscopy, there are different regions. If you are using the visual, then you can say the visual spectroscopy. If you are using the near infrared, you can say that infrared spectroscopy. If someone is using the infrared spectroscopy, MIR region of the electromagnetic radiation, then we can say that it is the medium spectroscopy. So those are students, remember that what is the range. If the visual and near infrared you are using, so its range is vary from the 380 to the 2500 nanometer, and mid infrared it is the 2500 to 25,000 nanometers. So that just be careful about the unit. Sometimes it is written the micrometer. If it is a micrometer, then it will go to the 0.38 micrometer to 2.5 micrometer, and for the MIR very convertible. So that there of spectrometer which are going in this instrument is in spectroradiometer is there. The handheld instrument also it is there. You can use it. So any of you want to visit to our laboratory, you are most welcome, and we will show you that the spectroscopy laboratory we are having, and I'm happy to say that Institute of Soil Science Bhopal that our laboratory, the Food and Agriculture Organization FAO Rome. So that is the big achievement for the India also. It has been recognized for the whole Asia regions, not India region, but whole Asia region. Besides the well-established the spectroradiometer, so you can see that in the market also there are some portable spectrometers. Any of you want to, if you want to use those spectrometer, can use in your research, and you can check it, you can quantify, you can that characterize those spectrometer for the for the different type of the support on handle instruments you are getting, and you quantify the soil's organic carbon, which is a very easy, very cheaper, and only the 10 rupees you are going to get a spectrometer. So if we will work for the soil's estimation of soil's organic carbon, your soil nitrogen, it will be very easy. So that this is the open arena of the research. Anybody can use those spectroscopy and quantify the soil assessment in their research work. So that now the question is that how many type of the spectroscopy are presently we are using, and what are the different ranges we are using for the soil assessment. So first one is the gamma ray, and here it is the passive gamma ray. That means the gamma ray is that releasing from the earth surfaces. So it is a passive, but it is mainly using for the soil textures analysis, EC and pH. So, but it is not very popular because its resolution is the very coarse. So the X-ray is also using for the heavy metal soil texture. So generally the X-ray is being used for the heavy metal analysis. So the X-ray fluorescence also we are having in our laboratory. UV region is although it can be used for the organic carbon, but not in the very much practices. And here you can see that under the serial number 4 and 5, I have marked the green color. So that these for the visual near infrared and for the mid infrared, that it is a very popular and throughout the globe, and many researchers even in India are using the VIR, visual near infrared and mid infrared for the research work. Okay, and it can be used for quantification of the all soil properties. I am showing you some of the above work we are doing in our the laboratory. So also the last one is the microwave, but microwave is mainly used for estimation of the soil moistures. Okay, so my slide is moving now. Hello.
Yes, sir. Yes, sir.
Yes, you are
It is
Yes, sir.
moving now. So that
Yes,
you
sir.
can see that how the now the question automatically come to your mind that why the spectroscopy is quantifying the different soil properties. You just see that in the soil there are the number of the band is there, kind of the OH band is there, CH band is there, NH band is there, and so that CO bond is there. The number of the band is there. When the some kind of the energy interacting with the soils, okay, so what will happen, that those bond observe those energy, electromagnetic radiation. So once the bond is getting a bond observing the electromagnetic radiation, whether it is a visual, near infrared, a mean infrared, so different kind of the vibration is happening. Here you can see that different type of the variation is happening. So vibration is nothing but it is occurring due to the observation of the electromagnetic radiation. So we need to quantify that through the machine learning and artificial intelligence in algorithm, which band has observed and that particular type of the electromagnetic radiation. So these things you need to quantify. So here you can see some of the examples. Okay, here examples you can see here that, for example, in the wave number, that is the 3620, the vibration is happening in the OH bond. Okay, in between the 3600 to the 2200 wave number, the vibration is happening in the OH and NH bond. Kind of the thing. These are the characteristic band where the different wave number are getting the observed. So the for soil properties also you need to quantify the which kind and what type of the band is getting vibration. That now question is that how you are getting, what are the process to get involved into, and what are the general methodology to quantify the soil spectroscopy. So here you can see that on the left hand side, this is the general methodology for the soil spectroscopy. Here what you need to do, so first you, after getting the soil samples, so different, you need to grind those soil sample. You can see that we are having with this instrument, with the spectrometer, the grinder is coming, coming with, and that you need to grind your sample and pass it to the 0.5 mm seal. So why we are doing that? Because if it is not the homogenized, not the properly grind, then the electromagnetic radiation is getting scattered. If it is getting the scattered, so the scattering information we don't want. So that then there is a hazy imagery, a hazy spectra is coming into. So we need to remove those spectra. So those scattering information. So to reduce the scattering, we need to first apply the first grind the soil sample. So after the grinding, so we put it the soil sample into this instrument, and then we are getting the soil spectra. I will show you how the soil spectra will look like, and then after the soil spectra, then we apply some pre-processing method. So that the error, other sort of the information which we don't want for our soil analysis, we are removing those information. So once those information we are getting, then some sample for the first time only, you need to analyze those sample into the laboratory, and then you try to make the model using the different method, kind of the partial square machine learning approaches, the kind of the random forest support vector machine. So you need to make the correlation and develop your model. Once your model will be developed, then you will validate it with the independent data set, and once it is validated, then it will be ready to use. So here you can see that for our studies, we are using the laboratory data, soil data. You can see that also that we are using the normal distributed data. And then in the second column on the right hand side, you can see that we are using the different pre-processing method. Pre-processing method are those kind of those methodology which are reducing the redundancy in the soil spectra. So that the number of the pre-processing methods are the standard normal variate, multiple scatter corrections, baseline corrections, Savage Gole transformations. So there are the different kind of the spectral pre-processing method. And the last column, you can see that there are the different machine learning approaches, modeling approaches we are using. That the PCR stand for the principal component regressions, PLS stand for the partial list square Q-based model, RF is for the random forest machine, and MBL is the memory-based learning. So there are the number of the combinations you can use it. So based on that, you will, by comparing all the 80 methods, yeah, sometimes it is more than the 200 methods, you need to select the best models for the soils analysis. So you can see that these are the regions of the machine learning models. So that you can see that if you are having the small data set, you can only use the top two, PCR and PLS data. If you are having the more data set, then you can go for the machine learning based model. Okay, so you can see here. So now that for our research, our study, what we have done, we have collected the more than the 4,200 soil samples from the different part of the India. Here you can see the 57 districts. We have we visited and collected the different soil samples, and our purpose is that we will have the different type of the soil kind of the, you can see the empty soil, watery soils, and alpine soil. Different type of the soil sample we are having, and together these three soil order covers in India about the same 70% of the agriculture's land. So that's why we have collected only the three type of the soil. After the collecting this type from the soil sample from these three orders, we have analyzed for the different soil properties. So you can see that we have done it for the soils organic carbon, pH, clay. The most of the soil properties we have done it. So some of the soil properties are visual here. So you can see that my purpose is that, and also make you understand that when you try to develop your own model, just you collect the soil sample which is having the high variability. You can see here for the soils organic carbons, we have collected the soil sample which is having the soils organic carbon as low as 0.3% and as much as it is the more than 2.5%. kind of the things you can also see in the clay pH ranges also. pH is varies from the pH 4 to it will go to the 9.5. So that my point is that if you are having the more data variability in your soil sample, your models, your machine learning model will be the more robust to use for the real world scenario. Okay, so I think that is the clear. So the after the soil analysis in the laboratory, because but only one time you need to do this practice. Once your model will be ready, then you can use your soil spectroscopy method. Okay, once your analysis is completed, you need to check that whether your data is a normal distributed or not. So here you can see that in the left hand side, it is a QQ plot, that is called the quantile plot. Here you can, if your line, the point is fallen on the straight line, it is then you can see that it is the normal distributed data. And if not, then it is not the normal distributed. It is not a normal distributed. Okay, the distribution is happening in your data set. So in left hand side, you can see that but the data is not normal distributed. So that we have applied some transformation analysis. For example, for the total nitrogen, we have applied the Cox transformation. Then on the right hand side, you can see that our data became the normal distribution. Like that, for the total carbon, so then after applying the Johnson normalization method, it will be the normal distributed data. So you can see here that for the different methodology, you need to, for the different soil property, we need to apply the different normalizations method. Okay, for example, you can see that pH के लिए that we are using the order quantile normalizations. For the soil, you see the logarithm is logarithms transformation is a performing way. So once we will have that the data transformation, the normalizations kind of the thing, then we will generate the soil spectra. You can see that after the generations, that your spectra will be look like this. Okay, you can see that, and also this is the spectra in the mid infrared spectroscopy, and you can see that this is the variations of the soil spectra among the different soil type. Here you can see that the blue one is the alluvial soil, the red one is for the red soil, and the green is for the black soil. So this is the variation. This is the average of around 100 spectra of each soil. So from the data spectra, you need to extract the soil informations. Okay, you need to extract the soil physicals, chemicals, and biological property. So that it is definitely it is a complex job, but as a scientist, as a student of the agriculture, for the betterment of our society, we need to do this thing. So here you can see that what are the possibility to extracting information. You can see here that on the left hand side, the clay content, the blue one is the clay contents is having the 92% of the clay, okay, of the soils. And the red one is the soil is having only the 3.4% of the clay. So here you can see that if the clay is varying that much, how the spectra is moving. Similarly, that on the right hand side, you can see you can observe the variation of the soil's organic carbon. Okay, so my purpose is that to show you that if the soil constituent is the different, there is the difference in the soil spectra. So there is the high probability to get the informations of the soil through the spectra. So that is my point I want to make here. Okay, so that you see there, this is a principles component analysis what we have performed there. Here you can see that a different color indicate the different location. So here it indicates that if you collect the soil samples, if you collect from the soil sample for that model training, model calibrations, you can see that. Then if you collect the soil sample from all those locations, your models will be the more applicable to all the conditions, because that you got this what kind of the model we are going to develop is the empirical model. You must know that there are two type of model is happening. One is the applicable that empirical model, another is the mechanistic model, empirical model of those models which is which only work within your data set. Here we are going to develop the empirical model only. If you are having the different informations for the different type of the soil, it will work for the all type of the soils. If not, then its information is the restricted one. Okay. So after the collecting the soil samples, what we need to do? We perform the different spectral processing methods. Okay. Here you can see that after the pre-processing method, how the different soil spectra is look like. Okay. First one is the raw spectra, then the SNV, that means we have performed the standard normal variate transformation. Then we can go for the machine, that MSC, that is the multiple scattering correction. So the kind of the different type of the pre-processing methods that we have applied. My purpose is to doing the pre-processing is that we are going to increase the soil information. That means in the scientific knowledge, we are going to increase the signal to noise ratio, SN ratio. In other words, we are saying that. So to increase the SN ratio, we are performing the spectral pre-processing method. And once you can see that dashed line, dot line in all the four graphs indicate that it is the unprocessed spectra. But the solid line indicate the this is the correlations between the soil property and a spectra after the transformation. And you can see that after all the four cases, there is the higher coefficient of correlations in the processed soil sample compared to the unprocessed soil sample. So that's why we are doing the soil pre-processing method. So once we have done with the soil pre-processing, here you need to arrange the soil spectra. Here you can see that we have arranged the soil, the higher the spectra according with the soil's organic carbon content in the soil. So here you can see the high soil organic carbon, low soil organic carbon, and mid soil organic carbon, and we have arranged those spectra. So we have done it for the soil's organic carbon, available phosphorus, and available potassium. So that this is the essential steps to perform to analyze it, to get the visuals, visual analysis of your soil spectra in correspond with the soil's property. So I'm leaving this. So that we have also developed the spectral predictions domain. So what is the spectral predictions domain? So this is a very good kind of the things. Suppose we have developed our own models. Okay. Okay, and I have kept it in our laboratory. If some of you is coming to our laboratory with the soil samples, and you will tell you that I have the 10 soil samples, and you go analyze my soil samples. So what we will do? We will grind your soil sample and put it in our instrument, and it will give the spectra. And now that I will matching your soil sample to the spectral prediction domain. And if your prediction, if your soil samples will be within the boundary, then we will able to say that predictions from our models of your samples will be quite good. Okay. And if it is outside our boundary, then we will say that prediction will be there, predictions will be there, but if there will be no confidence level. Confidence level is very low in that prediction. So it is the very good informations. Okay. So that's why we have developed for that our whole spectral library, because now we are having the more than 10,000 soil samples, and we have developed our own library, so that there are many type of the soil analysis we are performing. So that this kind of the information is a very useful for the students, MSc, PhD, even for the farmer. Okay. So that you can see that how that it is working. So here you can see that that we have performed analysis for the most of the soil sample, and you can see that for the total organic carbon, the last row, you can see that R square is the 0.8285. That means compared to the conventional method, if we will do the total carbon analysis, then our correction is more than the 80%. And for that, if for the laboratory method, total carbon will get the analysis in the, it cost around the 1000 rupees. But for the total carbons in the spectroscopy method, it is very easy to get and it will come to the 510 rupees. Okay. So kind of the things, the cost reductions will be happening, and only one time investment is there for the instrument. For the longer run, it will be the very easy. Spectroscopy is the very easy. Then for the soil pH, you can also see the R square is the quite high, that is the R square. So that you can see that this is the method for the validations. The total copper, and we have compared all the 80 methodology, all the 80 combination, and we have identified the which is good for the micronutrient as well. This is for the copper here, this is for the zinc here, and for the summary I want to see here. Till now we are able to validate the 13 parameter, that is the percentage clay, sand, silt, pH, soil organic carbon, available plant available, permanent built-in point water, field capacity, total carbons, and exchangeable potassium is also coming good, and all the micronutrients. So these results are the coming goods, and for the other soil parameter we are working on, and very soon we will succeed to get the informations from the different soil properties as well. So that now the question is that which band is the most sensitive? So here you can see that for the total organic carbons, our most sensitive band is around the 1300. So here you can see that this band is the most sensitive to identify the total organic carbon. Similar for the pH, that the 1600 band is the most sensitive for the quantification of the soil pH. So like that, we have done it for all the properties. Okay. So here you can see that we have used for the model tuning or the model validations, we are using the different hyperparameter to tune the model. So that
नमस्कार। कभी सोचा है कि ये जो हमारी प्लेट में इतने रसीले फल और ताजी सब्जियां होती हैं, इनके पीछे का विज्ञान क्या है? आज हम लोग इसी कमाल की दुनिया में उतरने वाले हैं, बागवानी, जिसे हॉर्टिकल्चर भी कहते हैं। हम देखेंगे कि इसकी जड़ें कहां से शुरू हुई और कैसे आधुनिक क्रांतियों ने हमारे खाने पीने का पूरा तरीका ही बदल कर रख दिया। तो इस सफर में हम क्या-क्या देखने वाले हैं? सबसे पहले हॉर्टिकल्चर शब्द आया कहां से, इसकी जड़ें क्या हैं, फिर इसकी अलग अलग शाखाओं को समझेंगे, जैसे फलों और फूलों की खेती। इसके बाद हम उस जबरदस्त हरित क्रांति की कहानी जानेंगे जिसने दुनिया की भूख मिटाने में मदद की। और हाँ, कृषि में और भी कई रंगीन क्रांतियां हुई, उन्हें भी समझेंगे। और आखिर में भविष्य की तरफ देखेंगे कि आगे क्या हो सकता है। तो चलिए एकदम शुरू से शुरू करते हैं। सबसे बेसिक सवाल, आखिर ये हॉर्टिकल्चर है क्या? मतलब क्या है इस शब्द का और ये आया कहाँ से? देखिए, इसका जवाब ना प्राचीन लैटिन भाषा में छिपा है। हॉर्टिकल्चर असल में दो शब्दों से मिलकर बना है। हॉर्टस जिसका मतलब है बगीचा और कॉलेरे जिसका मतलब है खेती करना। तो सीधा सा मतलब हुआ बगीचे की खेती, है ना एकदम सटीक। अच्छा, अब हॉर्टिकल्चर को ना एक बहुत बड़े पेड़ की तरह सोचिए जिसकी कई सारी जरूरी शाखें हैं। चलिए इसकी 4 सबसे मुख्य शाखाओं पर एक नजर डालते हैं। तो सबसे पहली है पोमोलॉजी, यानी फलों का विज्ञान। सेब से लेकर आम तक सब कुछ इसी में आता है। रोज की सब्जियों की दुनिया और खेत से हमारी प्लेट तक, ये अपने आप में भाषाई अपवाद है। इसमें जो पोमम शब्द है वो तो लैटिन से आया है जिसका मतलब है फल। चलिए अब बात जबरदस्त छलांग थी जिसने दुनिया से पहले 1960 की तरफ बढ़े, जिन्हें उनके काम के लिए 1970 में नोबेल शांति पुरस्कार तक मिला था। और भारत में इसने जिन्हें आत्मनिर्भर बन पाए। इसका सीधा संबंध दूध निर्भर बनना। फिर आबी क्रांति, ये एक साथ दो थे। लाल क्रांति ने मांस और टमाटर का उत्पादन बढ़ाया, तो सिल्वर क्रांति ने ये सच में। अब ये तो साफ है कि खेती का विज्ञान याद रखनी है। पहली कि हॉर्टिकल्चर हरित क्रांति ने खाद्य उत्पादन क्षेत्रों को आगे बढ़ाया। इसी देखिएगी, ये एक ऐसा सवाल है जिसके बारे में हम सबको सोचना चाहिए।
will take 30 seconds, single second.
I think sir had disconnected, but I am trying to connect him. Sir, actually, sir, have some technical issue. He is joining soon. Just wait 2 to 5 minutes.
Hello. Hello.
हेलो सर। हेलो।
जा रही है ना आवाज?
यस सर, आवाज आ रही है।
एक मिनट, लास्ट स्लाइड बच रहा था, मैं आपको फिर बता के डिस्कशन करवा देता हूँ, ठीक है? कैसे हो गए? So that I was talking about the soil SQI cal. Okay. So that was just I want to share that if anyone want to work in their in postgraduate research and PhD, this SQI cal software is a very that anybody can use it. It is a the data in a CSV format, and automatically by clicking some buttons that some the menu driven options, you will can calculate the SQI cal, so that it is easily available, and also that is the working video is available on the YouTube, and you can go there and visit those videos. And another thing is that what we have done, we developed the site specific the fertilizer management tools, and then it has been released in the last ICR Foundation Day by the Honorable Agriculture Minister Shri Shivraj Singh Chauhan ji. So that here that we have done it for the whole the Madhya Pradesh and for the Haryana, so that with this mobile app that farmers if farmers will stand up in their field and able to and will open this mobile app, then then the farmer will get information of the soil property, that is the soil nitrogen, phosphorus and potassium. Presently it is for the three properties only, and also that this is going about that if you search the e-form that
I think sir have some network issues.
it was my last slide. Just I want to show that directory was visiting in my laboratory, and it is so that so with this that I'm putting my lecture here off here. So if you are having that any question related to the soil spectroscopy, and I'm here to answer those questions. Please, I encourage you to ask some questions so that I will clear your query.
Thank you very much, sir, for such an enlightening, forward-thinking session. Your insight in infrared spectroscopy and soil health have truly expanded our understanding of the future of agriculture. Now, we would like to open the floor for interaction. Participants are encouraged to ask their question, directly engaging with Dr. Sinha. Dear participant, you can unmute your mic to ask your question, please. Here you can ask your question by unmuting your mic. If anybody else any question.
Yeah, what you can do that if not asking that question, that you share my email and with them, so that in future also if they want.
Hello, sir.
Yeah.
Good evening, sir.
जी Vikram Singh ji,
Sir,
बताइए.
Sir, my name is Vikram Singh. I am belong to the UP district Jaunpur. Sir, I know about the. I would like know that PCR is also used in the detection of the disease, and how can use the PCR in the soil, sir?
Okay, PCR that this is not that